let's practice these two ideas. These are actually both the patterns, because when I look carefully, I notice that this is a perfect square. The beginning's a perfect square. The end is a perfect square. Okay, and I notice it here too. That's a perfect square. And this is also a perfect square. So all of these are actually just those patterns that were just on the other page, where you just have to recognize, well, what times what gives you the front, what times what gives you the back, and then just decide the signs in between. So, all right, so since the beginning and the end of each of them are perfect squares, let's just break it down into, I don't think that's one. All right, so that means we've got binomials. What times what gives me 16y squared? Well, that's, pardon me, that is 4y and 4y. 4y times 4y will give me 16y squared. What times what gives me 25? Well, that's 5 times 5. So the beginning term goes in the beginning of the binomials, the end term goes in the end of the binomials, and then since it's subtraction, then that means this is a they're both subtraction. Because remember, this one is a trinomial. Okay, so the trinomial means the signs need to be the same, okay? And again, instead of writing them separate, we usually write them squared. We write it like that so that it's just a condensed version, okay? So then these are also perfect squares. So we say, okay, what times what gives me 4x squared, pardon me, and that would be 2x times 2x, because 2x times 2x would give me 4x squared. Okay, what times what gives me 81? Well, that would be 9 times 9. If you notice, they all square root. The fronts and the backs, they all match. That front and that, they match each other, okay? But since it's a negative 81, okay, that tells me that a negative 81 means that one has to be positive and one has to be negative. Since we have a binomial right here, okay, since we have a binomial, that tells me that these need to be opposite of each other. Trinomials, they're going to be the same. A binomial, it's going to be opposite. So there is that factor. Okay? Didn't have to do the x, didn't have to do the box. If you recognize those perfect squares, and then you just recognize trinomial or binomial, it could go faster for you, okay? All right, so then we have to kind of put all of what we know together. Okay, we have to put it all together, where we have to start with the flow chart, and we have to say GCF, and then break it down to the different branches. So this is, it says factor out a monomial first. So that is the GCF. GCF. Okay? You always want to look for the GCF. I just wanted to break it down into the different things you could see before you worry about seeing the GCF every single time. But you always want to look for that first. Always, always, always. We're just starting to get into that habit now, okay? So if you notice, both of these can divide by a 4. So that's why there's a 4 out front. Okay? Let me get a color instead. That's why there is, oh, that's not good. Ooh. That's why there's a 4 out front. Okay? So if I divide both of those by the GCF, which is what we did when we were dividing, okay, 4x squared divided by 4 is just x squared, minus 4 divided by 4 is 1. Okay? So the first thing we did was GCF. On that flow chart, that's the very first thing. That's that like big star or burst or whatever, okay? Then you've got branches. So you ask yourself, well, which branch is this? What is all right, so what is this? Okay, what type of terms, how many terms is that? Well, that's 2 terms. So under 2 terms, we have a pattern. And the pattern is that if you can square root the front, what times what gives you x squared? X times x. And then if you can square root the back, what times what gives you 1? That's 1 times 1. Since it's a negative 1, it's one's positive, one's negative, okay? So this is taking it into GCF, then one of our 3 different directions. This was the 2 terms, and then we just followed the pattern. So looking here, you factor that a little bit more. That's why we've got all these arrows, because you start somewhere and then you could go in all these different directions, okay? All right, so again here, GCF. The GCF is, they told us, negative 3y. So if I divide each of these by negative 3y, okay, let me get it maybe a little bit better green. All right, negative 3y squared divided by negative 3y is just a y. Okay, because those cancel out and you have one of those y's left. Negative 18y divided by negative 3y. Negative divided by negative is a positive. 18 divided by 3 is 6. And the y's will cancel. So this is just y plus 6. Well, once you've done GCF, you notice that this is only 2 terms, just like this one was, but this isn't a pattern. It's not squared, that you can't square root 6, so we're actually done with that one. Okay? All right, this one, the GCF is a 2. And that's what I thought. It's actually a negative 2, which makes way more sense. So divide everything by negative 2. All right, negative 4m squared divided by negative 2 is 2m squared. Okay? Negative 10m divided by negative 2. Negative divided by negative is a positive 5m. 24 divided by negative 2 makes that a negative 12. Okay, so watch your signs, watch your variables, all that. Then we have to ask ourselves, well, what is this? Okay, this is a trinomial, or it's a trinomial, but you can also call, on your flow chart, it says 3 terms. Okay, so we would go to this part of our, we would go to this direction of our flow chart. It's 3 terms. So is this advanced or is it basic? Well, unfortunately for us, it's actually advanced. It's advanced because there's a number right here, so that makes it advanced. So then we would have to go to our X and go to our box, which is what we did on the last video. So I would multiply, let's see if I'm using a different color. Multiply first times last. I get 2m squared times negative 12 is negative 24m squared. Put that in the middle. That's a 5m. Okay, so I need to think of my factor pairs. 8m and 3m, they multiply to almost to 24. One of them needs to be negative, so let me make the 8 negative. Okay, so these multiply to negative 24, but they don't add to 5. They almost do. They add to negative 5. So change the signs. That one should be positive. That one should be negative. That is what goes inside of our box, remember. Okay? We found these to go in here. So I'm going to put 8m in here. I'm going to put negative 3m in there. And then don't accidentally use these. A lot of people accidentally use those. Remember, it's the beginning and the end of the trinomial that goes inside your box. So that would be 2m squared, and negative 12. Okay, so the beginning and the end go in the beginning and the end of your box. We broke apart the middle because those two need to go in each corner, okay? Then we just GCF and we're done. And I know this takes a while, and that's what factoring does. Okay, when I go up the row, it's up the column. When I go up that column, it's a 4. When I go down this row, it's 2m. When I go down this row, it's negative 3 because they're both negative. And let me just check myself. 2m times m is 2m squared. 4 times 2m is 8m. m times negative 3 is negative 3m. 4 times negative 3 is negative 12. So each one of those has checked. If it didn't check, then you need to probably look for a bigger GCF. So m plus 4 is one factor, and 2m minus 3 is the other factor. Okay? So that is one of the longest types of factoring, GCF, and then the advanced trinomials. They really do take longer, but the more you do it, the more you get used to it, and it does get easier. Just you got to get used to it for a while, okay? All right, so this last one, they tell us that the GCF is a 5. So down the road, you have to practice getting GCF yourself, but in this case, we know it. So divide a 5 out, and we're left with z squared. Negative 25z divided by 5 is negative 5z. 40 divided by 5 is positive 8. Okay? Then, this is a trinomial, 3 terms, but it would be basic. Okay? So, if you go to a basic trinomial, you just make your x. And what multiplies to 8 and adds to negative 5? This is where we just do the end and we do the middle. Well, there's only 2 factors, 1 and 8. And even if you make it negative, can't make it negative because, well, you have to make them both negative. But that doesn't add to negative 5. And then the only other pair is negative 2 and negative 4. But those don't add to negative 5. So since there's no pair, okay, remember that means no solution, that means doesn't exist. So this is where we stop. That's as factors as it'll go. You can't break it down anymore. So you keep trying until it stops and you can't do anything more. Okay? All right, so the last page is more practice of those things. So we will go through and practice some more, okay?